Okay, we're going to continue with our next talk. We're delighted to have Ethan Bueno de Mesquita here. He's the Dean of the Harris School of Public Policy at the University of Chicago. He was a visitor here last summer as well. Welcome back, Ethan. Take it away.
Thanks. Great. So this is some joint work with my colleague Viola Judah in the Policy School, as well as Haifeng Zhu in the Computer Science Department at Chicago. This is not, we had planned on writing a governance paper about AI. And then when we started thinking about that, realized that we didn't know the answer to any of the questions that come kind of to the left of that. So before we can write a governance paper, we felt like we had to figure out some things about the way AI is going to interact with the part of the market we're interested in. So this is going to be a sort of a prior to that paper about the ways in which at least one way of thinking about the role of AI in the economy and in particular as it relates to production and innovation. So the sort of inspiration for thinking about this, actually, I mean, I put these up here, but actually I think the inspiration for thinking about this came from like a series of phone calls with Andy, where he told me that AI was going to destroy the internet by making nobody produce anything because everything was going to be free and then everything was going to be garbage. And it turns out the whole world is worried about that we're going to be able to create we're going to be able to copy everything, right, at zero marginal cost, and then everyone's going to stop producing things, and that's going to be horrible. My favorite version of that is this conversation on Hard Fork between Kevin Rouse and Casey Newton. You can read it yourself. I won't try and recreate it for you. But they're having this debate about like, well, once you can create everything at zero marginal cost, is everything going to be garbage and blah 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 blah. And Casey's pretty sure that's the case, and Kevin is a little bit skeptical. And both in this discussion and in all of these discussions, there's a real lack of, in some sense, there's a lack of economics going on, in that I don't think you can have a serious conversation about the effect of AI on, say, the creator economy and the like without thinking about prices. And the conversation almost always lacks prices, in part because I think people think, well, AI is going to do things at zero marginal cost, and so we can stop thinking about prices, and I think that's quite wrong. So we wanted to think about what does the market for content look like in a world in which there is AI that's training on past content, disrupting the market in various ways, but where we take prices seriously. So I'm going to, very strangely for me, I'm a political economist who does game theory. I'm going to give you what is essentially a price theory talk to try and think about AI, content production, and incentives for innovation. So that's what we're going to do. We're going to model a market for content. We're going to have an AI in the model that trains on past content and produces potentially lower quality substitute goods at zero marginal cost. Human producers are going to make choices about whether to try and compete with the AI or innovate to new markets where there isn't training data that they're currently competing with. And we're going to ask questions like, how does AI affect prices, production, consumption, welfare? And today what I'm going to focus on in particular is innovation. And what I'm going to show you in the model today is that AI actually can have a variety of effects on innovation, and it will depend critically on the kind of good we're thinking about innovating to. So AI is going to, it turns out, we think, at least in the model, deter innovation when that innovation is into substitute goods, and it's going to spur innovation when that innovation is into sort of what we might think of as independent goods. I'm not going to think about the case of complements today, but I think the case of complements is going to be sort of a more extreme version of the case of independent goods. So let me jump right into the model. Okay, so I'm gonna try and be ridiculously simple, and I should say this is extremely preliminary work, so your comments are welcome. We're gonna have two periods. We're gonna have two markets. That is to say, we're gonna have two different kinds of goods. We're gonna have a unit mass of producers and a unit mass of consumers. In any period, human producers are going to produce a good X in the market M, and the AI is going to produce a good Y in the market M. We're going to talk about the technology of AI in sort of pretty abstracted terms. So we're just going to have, in some market M at period T, there's some past production that's gone on. Okay, so there's total past production in this market. And the AI is going to train on all of that past production. Okay? And so the quality of the product that the AI can produce in that market is just going to be some function of all the stuff that's been done in that market before. It's going to be, right, an increasing function. And if there's no training data, it produces something of no value at all. Okay, so like the kind of, I don't know, the sort of, to fix ideas, the kind of product we have in mind is like you make movies, right? And there's lots of movies out there, and AI can train on movies, and then it can produce its own movie, and how good that movie is depends both on sort of the technology of AI, so we're going to think about changes to this function queue, as well as the amount of data that it has access to, all the movies of the past, which is this quantity X. And so AI can improve for two reasons. One, there's more training data than there used to be, and another is that we've made a technological breakthrough that just like increases that function in some way.
Ethan, can I just like to kind of jump into where I think this is going? Like, it seems like the key part of the optimism you want to impart is coming from there's this like other new market, and the AI is not helpful in that other area because it has no past training data. Like,
that's going to be part of the optimism. Yeah, is like it's going to spur, sometimes depending on the new market, it's going to spur people to look for new things to do, right, where training data doesn't exist yet, and that's going to give them some space.
So I basically believe that model of optimism, but let me push on it for a second. If you believe that like all human innovation is also recombinations of existing information, a lot of people, I think, argue that the AIs are just going to be sort of so much better at this recombination process that there essentially are no independent markets, that there is like, no space that a human could move into and like do recombination of ideas in a way that is better than what the AIs could be doing the second they discover the market exists. Is that going to sort of break if that were true, would it break the claim you're making?
Yeah, good question. So so one of the things that's on our list to do is to think about thinking about if training data crosses markets but imperfectly, how much worse is the news, right? And I think that's in the spirit of it. I don't think like.
It's true, although I'm sort of asking the converse question, which is that if humans are doing the same type of process as AI.
Yeah, but that's right? That's exactly, yeah. So so let me say, maybe we're getting into philosophy, I don't know, but I'm skeptical that humans are doing the same process as AI, at least as AI is currently constructed.
Totally agree with you. Look, absolutely agreed.
Yeah. So yes. So for sure, if we think about an improvement to AI that looks like AIs are just as good at humans at innovating to new markets and can do so at zero marginal cost, that's going to be a straight bad news story for human producers, and a really good story for human consumers.
Absolutely, and understood that at that level it becomes tautological. But my question is, in some sense, if like. Well, and I guess I haven't let you show the human model yet, so maybe I'll defer this until after you describe how the humans work. I'm trying to figure out how different the human processing technology is.
Yeah. So let's think about that.
So I have one quick question. In your previous model, do you also want to include previous contents that the AI have created into your X, or is it just part of?
So it's not going to matter in this in the current version of the model, because I'm going to do a 2-period version of the model. In our ambitions over the long run is thinking about is a more properly dynamic model, and then I think there's a good question to be asked about whether you want to let the synthetic data also train the AI or not, and whether that. So I'm gonna defer that because I don't need to take a stand on that today, and I'm also going to defer it because to the extent that we have to take a stand on it, I'm going to let my colleague from the computer science department tell me what the correct answer is. I for the life of me cannot understand how it is possible that synthetic data can improve the AI. That makes no sense to me at all. But I know that I must be maybe wrong about that, although I don't think so. So the timeline's going to be super simple. In the beginning of life, there's just the one product in the one market. The human being is going to, there's no training data, so the AI is not there. Human being's going to create it. The consumers are going to consume it. We're going to have prices that clear the market because we work at the University of Chicago. In the second period, producers are now going to have a choice to make, which is that they can keep producing in market one and compete with the AI. They can innovate to market two for at cost, so they have to pay something to innovate, but they can do it, and they can produce in market two where they're not directly competing with an AI, although they're going to be indirectly competing with an AI for consumers' attention, or they can exit the market entirely if they want to. So if the AI gets good enough, there may be no profits to be made, and everybody may exit the market. Consumers then consume all three goods, right? Human-produced goods in both markets, as well as the AI-produced good, and again, prices clear the market. Payoffs, again, I'm going to try and keep everything kind of simple. Consumer payoffs are going to be a little bit complicated. I'll show you in a minute. But producer payoffs are really simple. So the profits to a producer given a price and a quantity produced are just price times quantity minus a cost of production, where I'm going to use a functional form for now, although it's not important, but this is just to keep things a little bit simple. And then if they decide to innovate in period 2, then they have to pay the costs of innovation. And let me just point out here, because we're going to record this for posterity, right? The first order condition of this says that the amount supplied by an individual producer is equal to the price given my functional forms, and therefore I can write the profits directly as a function of price. Okay, and I'm going to use this notation throughout: the profits given the price in the market. Consumers. In period 1, consumers' preferences are also super simple. They just have some enjoyment of the good they consumed, and they have to pay for it. So this is the price times the quantity consumed, and they're linear in money. In period 2, I'm going to make it a little bit richer, in part because much of what I'm going to do here, in some sense, I don't need, but I want to have a model in which we might have innovation, even absent AI. Okay, so what am I going to do? I'm going to think about 2 different versions of consumers. One where the goods are straight substitutes. Okay, so I get some utility from everything I consume, and each one is as good as the other. I can substitute them around, and I get so market 1 and market 2 are substitutes here. Okay, so that's my enjoyment of the good. And then what am I going to do here? This term is what you might think of as a model of boredom. Okay, so if I've already consumed good 1 in the first period, I'm going to discount my marginal benefit of consuming good 1 in the second period by an amount that's related to that. Okay, so if I consume good 1 in the second period also, my marginal benefit from consuming it is going to be this u prime as normal minus this alpha that comes from having consumed it in the past. Okay, so if we think of good 1 as Victorian novels, and I've already read a bunch of Victorian novels yesterday, today, I might enjoy another Victorian novel, but not as much as the first one. Now, first one was really magical. Okay, so I'm getting bored with this product over time.
Empirically speaking, that doesn't seem to be the way social media consumption works.
I don't think we know, empirically speaking. I don't see how we could possibly estimate that. As a matter of introspection, I find that I get bored with things after I consume them for a while, and I want something new.
I guess it depends the level of granularity which you are.
Sure. What I'll say is that there is nothing important about doing this other than it is what drives it gets me incentives for innovation, even absent AI, which seemed like a feature of the model that one wanted. Was you get saturated with a good, and there's reasons to produce the other good. If I told you there's no innovation ever, and then we introduce AI, which competes away a market, and now we get innovation, that would be a little bit So we wanted a model that allowed for incentives for innovation over time because people were they had consumed enough of a thing.
Do you think should I be thinking about Victorian novels and then the new market is some other type of novel, or should I be thinking the market is books?
Good. So it depends on whether or not you want to think it depends on my 2 models whether they're substitutes or independent. So one way of thinking about it is Victorian novels get replaced by modernist novels, right? And that's an innovation. Somebody had to figure out how to create a modernist novel, and that's the new thing. But those things are substitutes. There's books are a category of good, and the new invention, which is a substitute for Victorian novels, is modernist novels. Yeah. If we think another thing that might happen is I might be reading novels, and somebody invents movies. And you might think that those aren't exactly substitutes for each other, but that my demand for those 2 things, I'm spending different chunks of my life on those 2 things. So that's exactly okay, so I'm going to discount the marginal benefit of consumption by past consumption in order to create incentives for innovation. And for the AI good, okay, because it's in market 1, I'm going to discount it for past consumption, because the AI is writing a new Victorian novel, and I'm already bored with Victorian novels. And also the AI good has a quality. Okay? How good this quality is depends on past production also. I should have written this as a function. Sorry about that. Right? But the higher the quality, right, the more I enjoy the good, and the lower the quality, the less I enjoy the good. So the marginal benefit of consuming a unit of AI is, again, this same u prime, now discounted by both my boredom, and if it's really low quality, discounted by its low quality also. Right? Q is the quality, 1 minus Q is the lowness of the quality. I will also do a version of the model where the 2 goods are independent. And all that means is everything here is the same, but I've got 2 separate enjoyment functions for the good because they're independent as opposed to substitutes for each other. It's not like I start watching movies and therefore I don't have time for books anymore.
Thinking,
Okay.
I realize the topology of these innovation categories is not completely fixed or determined in this setup, but like, should we think of there as being very large numbers of independent categories yet to be or markets rather yet to be discovered over time?
Yeah, that's how I would think about it. Okay, so what I'm going to do here is, my plan is I want to show you market equilibrium completely without AI. And then I'm going to ask what happens to equilibrium as AI quality improves, where when I think about AI and quality improving, I'm not going to be thinking about an increase in the training data, but rather a change to the function queue, right, which is a technological improvement in our ability to turn past data into products. Okay? And I'm particularly interested in how much innovation there is. I'm also going to be interested in what gets consumed in prices. Okay? Let me start with period 1, which is the same across all the models I'm going to study. And we'll just like give us an idea of like how you solve a model like this, right? It's very simple price theory. But because all of the actors here are small relative to the economy, right? They're all price takers, and they don't consider their individual effects on the future quality of AI. So I'm not going to write my novel today because tomorrow my 1 in a million novel is going to increase the quality of AI, and that's going to put me out of business. I'm not having those thoughts because I'm small relative to the economy. Okay, so what happens, this is Econ 101, right? Demand here looks like consumers maximizing their utility, which is, right, this is the marginal benefit of consumption, this is the marginal cost of consumption, and so we can get a demand function out of that. Producers, we already looked at the producers' optimization problem, so they're going to maximize their utility by choosing their supply, and we're going to clear the market through prices, right? So that just looks like literally the Econ 101 picture, that demand is decreasing in price, supply is increasing in price, and we're going to get a price and a quantity out of equilibrium. I'm just going to define for you 2 quantities I'm going to use throughout, which is the equilibrium level of boredom in market 1. Okay, I'm going to call that alpha hat, and the equilibrium AI quality, which I'm going to call Q hat. And so when I think about introducing improvements in AI, what I'm going to think about is increases in in Q hat, which is a technological improvement, right? X1 star is fixed. And what I'm thinking about is like if we invented some better, right? We invented transformer technology, whatever, and we now have higher quality AI fixing the amount of training data. Okay, so now let's actually talk about the model where all the action happens in period 2. So let's think about equilibrium without AI. And I want you to start by considering the case where in period 2, both markets are going to be active. So there's some level of innovation, even without AI. Okay, when that's true, notice, since there's no AI, producers in market 1 who don't bear any fixed costs are clearly making positive profits. And if you're making positive profits, you're not going to exit. So if both markets are operative, that means all of the producers, nobody has exited. Either if you don't want to pay the fixed costs in market 2, you may as well stay in market 1. You're making positive profits. So we're going to say the share of producers who go to market 1 is lambda, and the share of producers who go to market 2 is 1 minus lambda. Okay, so we've got this unit mass of producers. Some will be in market 1, some will be in market 2. It's going to sum up to 1. Okay, so this is the measure of producers in market 1, the measure of producers in market 2. What does equilibrium look like? Okay, what does equilibrium look like? We get demand in the usual way, right? So consumers are maximizing their consumption choices, their utility with their consumption choices, right? So we get 2 first order conditions because they're choosing 2 goods. So this is the marginal cost of consuming good 1, where it comes from 2 things, right? The price, and also you're consuming a thing you're bored of. This is the marginal cost of consuming good 2, which is just the price. You're not bored of good 2 yet, right? And because they're substitutes, they're inside the same benefit function, which means that if consumers are in fact going to buy both goods, they must be indifferent as between them, which is to say that the price of good 2 has to be higher than the price of good 1, right? And in a way that exactly offsets boredom. Otherwise, consumers would go to a corner and consume only 1 good. Okay, so we know we get that price 2 is determined by price 1. And so what does that look like? This black curve here is the profits from market 1 at price 1. This curve is the profits from market 2 net of the costs of innovation at the price 2, which holds consumers indifferent. And the equilibrium price has to make the producers indifferent, because if we're going to have producers in both markets, the producers also have to be indifferent, right?
So in your previous slide, are you assuming each consumer is consuming only 1 unit of item?
No, they're consuming continuously.
Then why they have to be like indifferent? It might be that consumer 1 consumes first item a lot more.
Because they're consuming both. So notice the left-hand sides of these 2 first order conditions are the same. And so if the right-hand sides aren't the same, then the solution is a corner solution. Right? This is because the two goods are substitutes. I'm as happy to consume one as two, right? So that locks in a price. Okay, so we've held the consumer is indifferent by fixing price 2 as a function of price 1, and then we've said, okay, well, the price has to be the one that makes the producers indifferent as between the two markets, because we're looking for an equilibrium where they're serving both markets. So now we are locked into a price 1, which locks us into a price 2. But we're not done with equilibrium yet, because we also have to clear the market, right? It has to be that the amount consumed and the amount supplied are the same. And we are almost out of right? In our kind of standard model, we'd be out of things to play with. We've locked in both of our prices. But here we have one more thing to play with, which is that the number of producers in market 1 and market 2 is also endogenous, right? And notice, remember, the amount a producer produces is the price, right? That was so the price is lower in market 1 than in market 2, which means a producer in market 1 produces less than a producer in market 2. And so equilibrium is going to require that the number of producers who go to market 1 and the number of producers in market 2 balances out so that we clear the market, so that demand equals supply. Okay, so we get one more set of conditions, which looks like this is lambda, right? As we increase the number of producers going to market 1, we decrease total supply holding fixed prices, which we've already determined have to be fixed at a particular number. Right? And that's because if you're in market 1, you produce less stuff because you're being paid less for it. Okay? And we have total demand at those prices, which is just a number. And so the number of producers going to market 1 has to be exactly the number such that supply equals demand. Okay? And so that's how you get equilibrium in this model with innovation. We are getting some equilibrium innovation, right? Not everyone is staying in market 1. And the reason for that is because of this wedge that comes from boredom. So just to fix ideas one more time about what's going on in equilibrium here, suppose that we are at equilibrium, right? We're here, and then we increase the cost of innovation. So it becomes more expensive to invent good 2. Now producers prefer market 1. Right? They're like, I don't want to pay for that. I was just indifferent anyway, and now it's more expensive. So what has to happen? We have to change prices to restore indifference. Right? What happens? How do we restore indifference when we increase prices? So here we increase the costs. Right? So the net profits of going to market 2 go down, so we got to raise prices. Once we raise prices, consumers now are unhappy, right? Because we made prices higher, so demand has gone down. If demand has gone down, we have to produce less. How do we do that? We got to move some people back to market 1, right? Where they're producing less. So we go from here, from our equilibrium, demand goes down, right? And so now we got to move people from market 2 to market 1. Okay? And that's sort of the mechanics of this model. Okay? So not surprisingly, raising the cost of innovation changes prices, in particular increases prices, and then shifts and drives down demand and shifts people into the non-innovative part of the economy. If we made K big enough, we would get rid of all innovation. And if we made K small enough, we would drive everybody out of market 1. And that's what this picture of. So this is the equilibrium amount of innovation. That is to say, it is 1 minus the lambda star. Lambda star is the number of producers in market 1. So this is the number of producers in market 2 in equilibrium. When the costs of innovation are low, we have a high level of innovation. Essentially, everybody's going to market 2. Okay? When the costs of innovation are high, nobody's going to market 2. And for interim values, we're getting some level of innovation. And now we can ask what happens to this equilibrium when we introduce AI, which can produce a lower quality good, but at 0 marginal cost. So what happens if I introduce AI? Well, I introduce this third first order condition for consumers, right? Consumers now can buy Y. Their demand for Y reflects, right? This is their benefit from marginal benefit from Y. Their marginal cost is the boredom plus the degradation of quality. Notice this means if P12 is bigger than 1 minus Q hat, right? If the price is large relative to the quality of the AI, nobody consumes X1. Nobody consumes human goods in market number 1 because they can just consume the AI. Okay, so the price of good 1 can't exceed 1 minus Q hat. And similarly, if the price of good 2, because these are substitute goods here, right, exceeds 1 minus Q hat plus alpha hat, because there is the boredom, nobody's going to consume good 2, right? So prices are now going to be constrained by the quality of AI potentially. suppose we're in this region where in equilibrium we were getting no innovation at all. Okay, so costs were high, nobody was innovating. What's going to happen? Well, if the quality of AI is really low, so that 1 minus q hat is bigger than the price we were charging in equilibrium anyway, it doesn't matter. AI comes in, it's crappy, everybody looks at it and says, I'd rather buy this human-made good anyway, and we just ignore the AI and nothing changes. But as the AI gets better, so that the 1 minus q hat dips below the price we were charging in equilibrium, now we have to start lowering our prices. Right? Humans have to lower their prices, and this is bad for, there's still not going to be any innovation. In fact, innovation is getting less and less attractive in some sense, but humans are producing less. The market is then being cleared by AI consumption, and this is good for consumers, obviously, because we're consuming a bunch of crappy AI stuff, but we're doing it for free, and we're consuming less human stuff, but the price of it has been driven down. Okay? So it's good for consumer welfare. If you take a more paternalistic view, people are reading crappy AI novels instead of real novels, and that maybe is too bad, but they're doing it really cheaply. More interesting is if we're in this range where we were getting innovation absent AI. Now AI comes in, again, if the AI is crappy so that its quality puts it worse than the equilibrium price, nothing happens. But as it gets good enough that it drops below the the challenge drops below the price we were charging. Now we have to, market one has to compete with the AI, so we have to lower the price for human good one. And that means then market two is competing against both market one and the AI, and we have to lower the price for good two also. Yeah, so both prices in both markets come down. And when both prices come down in a way that still holds consumers indifferent, that makes market two relatively less attractive to producers, right? Here's the picture of that. We were here at the equilibrium price where producers were indifferent between the two markets. We force P1 down to 1 minus q hat, right? And now what's the pay? And P2 is P1 plus alpha hat. And so now market two has become relatively less attractive, right? Here's market two, and it used to be that we were indifferent between them two, but now we strictly prefer market one. Yeah? And now we're out of ways to restore equilibrium, right? We forced the price here, and at this price, producers are not indifferent. They strictly prefer market one. And so now innovation, which was positive in here, has completely collapsed, right? So AI came in, it forced the price in market one down, that created competition for market two for the substitute good, force the price of market two down, and now producers look at it and say it's not worth the price of innovating, and they go from lots of them innovating to absolutely nobody innovating. Okay, so in this part of the market, AI completely destroys all innovation.
Maybe footnote question: what would happen here if the AI also improved the human's ability to innovate? So it has some facility to help them do the thing that they couldn't do as well before?
So if by that we mean it lowers the cost of innovating, then if it does so enough such that the gray line and the black line flip again, right, then it's going to put us out of equilibrium except for in a non-generic case. But how good it has to be or bad it has to be to destroy innovation versus encourage innovation is going to be a horse race between this price effect and this cost effect.
What about, I'm just thinking about time periods here. So if there were many time periods.
I'm going to talk about that at the end. So I think an obvious next question is imagine there was just one more time period. Another thing AI does is affects the continuation value, not only in market one, but in market two, right? Because in market two, we're going to get AI tomorrow. But notice we're producing less in market two than we are in market one. So the horse race between market two and market one still favors market two with AI. So we think under reasonable assumptions, everything we're saying here is qualitatively true in that model too.
Why are you saying that it's putting us out of equilibrium? Isn't this a new equilibrium that we now have?
I'm sorry, we're always, of course, in equilibrium. I'm saying it's putting us out of, if we had producers in both markets, that's no longer in equilibrium. Innovation collapses, and in the new equilibrium, everyone is in market one. Yeah? So it takes this range where we had innovation absent AI, and it obliterates it. And now we have no innovation. For this lower range where we were getting lots of innovation, no one was going into market one, right? AI is worse than good one, it can't compete with market two. Market one couldn't compete with market two. AI also can't compete with market two, and sort of nothing happens here with AI, okay? So really the interesting effect is in the world where we were getting innovation absent AI for substitute goods, when AI comes in, by forcing down prices, it obliterates innovation. It is nonetheless good for consumer welfare on a sort of a pure kind of like, utilitarian welfarist view. So I'll skip the summing up, but that's the idea. Okay? In this world where we were getting human innovation, AI destroys it when the goods are substitutes. Let me tell you about what happens when the goods are independent instead of substitutes. Okay? So what do I mean here? What I mean is, right, that the users, I guess I didn't rewrite it, but that the consumer's utility, right, is additively separable in market one goods and market two goods. Okay? So they are neither substitutes nor complements. The cross partial is 0. So again, just like before, we're going to get demand out of first order conditions, but now, right, it is not the case, I don't remember who asked it before, it is not the case that the left-hand sides here are the same. Right? The consumers no longer need to be indifferent between the two goods to consume them both, because they're going to balance their marginal benefits and marginal costs. And if I've already consumed a lot of this, right, the marginal benefits of this are going to be bigger, and I'm going to start consuming it also. Okay? But nonetheless, we're going to get demand out of this, right? And we don't have to have consumer indifference. We still have, if we're going to have producers in both markets, we still have to have producer indifference. Right? Producers are still making choices, so it must be that the profits I'm getting in market one and market two net of innovation costs are the same, and that's going to lock in again the price in market two as a function of the price in market one. So what does market clearing look like? So I've got right, I can get demand from here by inverting this function, demand from here from inverting this function. So this is market one demand. Market one supply is everybody in market one is producing this much. There's this many people in market one, so that's supply in market one, yeah? And so if I ask myself, how do I clear this market? I got to choose the right number of people to be in this market, right? Given the price, so fix a price. We haven't determined price yet in equilibrium, but fix a price. I got to get the right number of people to clear the market. So that looks like this, right? Here's total supply in market one. Here's demand in market one. That's the number of people. Lambda star of 1 is the number of people I need to get into market one to clear market one, given a price in market one. I can do the same thing for market two. Again, lambda and 1 minus lambda have to sum to 1. Here I'm still on the x-axis saying the number of people in market one, so the number of people in market two is 1 minus that, right? So the total supply in market two is decreasing in the number of producers in market one. Okay, and I'm going to get the number of people I need to send to market one, given that the balance are going to go to market two in order to clear market two. Okay, so now I know that given a price one and a price two, I know the number of people I should send to market one to clear market one, and I know the number of people I should send to market one to clear market two. Those numbers better be the same if I'm going to have an equilibrium. But I'm not done yet, right? I also, so first thing to see is that the number of people I need to send to market one to clear market one is decreasing in the price of market one. That's obvious, right? If I make good one more expensive, there's going to be less demand for good one, and there's going to be more production of good one. So I need to send fewer people there. Okay, so I won't belabor that point, but that's just this. Supply goes up when I increase the price. Demand goes down, and so the number of people I need is smaller. The number of producers I need to send to market one to clear market two, if the price goes up in market two, is going the opposite direction. Again, that's kind of obvious. I won't belabor that point. There's one more fact we know to lock in equilibrium, okay, which is that we know the price in market two given the price in market one. Okay, so I'm going to be able to take these quantities, right, the number of people in market one who clear market one, the number of people in market two who clear market two, given prices, and the fact that the prices are related, yeah, and I'm going to be able to find equilibrium. So that looks like this. This is the number of people I need to send to market one as a function of the price in market one to clear market one. This is the number of producers I need to send to market two, given a price in market two, which has to be this function of the price in market one to clear market two. And in equilibrium, I need to clear market one and market two, right? And that's going to give me a unique price in market one, a unique number of people in market one, and then from this function, a unique price in market two. Okay, so again, I have a market equilibrium. It has people in both markets. It has unique prices and a unique number of producers in each market. I can do, again, the standard comparative statics, right? If I increase K, this will shift up. I'm going to change the price of it, and eventually I will lose one of the markets or the others, but I'm going to worry about that. So now I'm just going to ask what happens to that equilibrium, again, when I introduce AI. Okay, so now I'm in this world where the goods are independent. So what happens if I introduce AI? Well, if I introduce AI, just like before, the price in market 1 can't exceed 1 minus Q if I'm going to have any demand in market 1 at all for human goods, right? Because the AI is a substitute for the human good in market 1. So if the AI is kind of crappy, right, worse than the equilibrium price I was charging in market 1, it doesn't matter. Okay? It is true that I no longer could, right, once we get to this point, P1 has to stay at 1 minus Q. But it didn't affect the equilibrium because it wasn't competing with us. But as 1 minus Q gets smaller, right, as Q gets bigger, as the quality of AI goes up, now all of a sudden I'm constrained, right? I cannot charge this price which cleared this market, right? These curves no longer cross. So what am I going to do to get equilibrium now, right? I cannot charge the prices that'll drive the market clearing memberships ticket, right? So what's going to happen in this case? Well, what's going to happen in this case is I got to find another way to clear the market. And I have a way to do it. And the reason I have a way to do it is because at the price 1 minus Q, consumers are indifferent as between consuming human good 1 and AI. So I can leave too few producers in market 1 and let the consumers in market 1 consume a bunch of crappy AI. I can send those producers to market 2 to clear the market in market 2 where there isn't an AI substitute. Okay, so what happens here is, right, I'm stuck here where these curves don't cross. And so what I do is I send everybody up to this level of participation that clears market 2. So I send the right number of people so that I'm going to clear market 2. I don't have enough people in market 1, but that's okay because I got AI in market 1. So what happens, right? How should I think about what's going on? What's going on is the AI comes in, it disrupts the equilibrium by forcing prices to be lower. That's good for consumers, right? It makes a bunch of producers who were used to be in market 1 go innovate. Right? They're facing lots of competition in market 1. They're like, I don't like it here anymore. I'm going to market 2. Now market 1 is way underserved, but it's okay because consumers are like, that's okay. I'll read Victorian novels written by the AI and modernist novels written by humans rather than, you see what I mean? Okay. All right, so to conclude, first of all, we think like first order thing about this kind of public debate going on, if we want to understand the effect of AI on producers and consumers in this kind of content markets, it really won't do to ignore prices. Prices are like the fundamental mechanism that make all of this go. And so this debate has really sort of gotten confused by failing to think about prices. Whether or not high quality AI is going to in fact disrupt these markets and leave us all reading garbage on the internet instead of reading good things, really depends on the kind of goods we're thinking about, right? So it deters human innovation into substitute goods. It spurs innovation into independent goods. It always, in this model, increases consumer welfare. Let me just say a few things about the next steps we're thinking about. Some things that complicate the model that we've done some work on. Suppose that in addition to this cost of innovation, there's a fixed cost of production, not just marginal cost of production. Okay? In that world, AI can in fact be bad for welfare. And one way of seeing that is think about that first period where you're doing a bunch of production. If you look down the tree and say, if we do a bunch of production today, there's going to be an AI tomorrow. That's going to erode our producer rents tomorrow. That could make it no longer worth the fixed cost of production today. Okay? So it is possible that even though we're all measure 0 and we don't affect the AI in the future, just the anticipation that the AI is going to be good tomorrow, which is good for consumer welfare but bad for producer welfare, could deter us from getting into the market today, could make there be less training data. And now you got to get to equilibrium and you're going to have like fewer producers entering the market at the beginning. Okay? So technological improvements in AI in the model I just showed you are always good for consumer welfare, but that doesn't have to be true. And in particular, it's not true when there's fixed cost of production. We have that model. We think, as I talked about with Andy, there's interesting dynamic considerations. And in particular, the innovation side of this model, AI doesn't matter for it all, right? The AI, like the fact that there's AI doesn't affect my thinking about market 2 in this model because the world ends after period 2. But of course, in a dynamic model, that's not true. We've worked on that too, and there is this horse race now. But because there's always more training data in in market one, at least for sort of concave production functions for the AI, that horse race is going to balance out, we think, in favor of qualitatively the kind of results we have here, although we're not done with that model. The last thing that we're starting to think about is, suppose the AI belongs to somebody. Okay? Now it produces who wants to make money. It produces at zero marginal cost, so the price of that good should be zero. Right? But if they can ration access to they could charge subscription fees. Right? So if I want to read Victorian novels written by ChatGPT, I got to pay my $20 a month. In that world, there's all sorts of interesting questions. One is just like, what does the price look like? But another, I think, is interesting and maybe could potentially undo some of this, which is the owner of that AI who is rationing and selling subscriptions is now going to have incentives to subsidize content production by humans, because they're going to want the training data, right? So if I can write a contract with a human that says, you generate content, I get to use it for training data, but also you can sell it on the market, I'm going to want to, right? Humans are not producing content at the optimal level for the AI owner. And so I think there's interesting questions about, like, what does the market look like as between an AI owner and consumers on the one side who it's selling subscriptions to, and producers on the other side for whom it needs to buy their content and maybe subsidize their content in order to have training data. And that's sort of a next step that we're starting to think about.